Hello, class. I'm going to go over the COREC number 8, Reading and Graphing Linear Inequalities. And I have noticed some of you have had an opportunity to finish that, so that's very good. So remember, you can always work ahead before your instructor's videos come out. There is a recommended list of attachment that you would download, a Word document that you would download, and it does have recommended YouTube videos for you to watch. Otherwise you would wait until the instructor provides you with a Zoom video. So remember, the Zoom feature is a fairly new tool that the campus has recently, Alamo College has recently purchased for the instructors. And so you just have to be patient because it does take time for me to review myself separately from all my other assigned courses. And then it does take time for the videos to generate and process. There's 5 files that makes it complete, and sometimes the 5th file takes long to process because it includes the translation, the wording in that. So sometimes I put the 4th file up until the 5th one generates. And so just keep that in mind. If you ever want to work ahead before your instructor videos come out, you're more than welcome to. You have your ebook. Um, the ebook also has uh, extra tips and things like that. You have your instructional tools and your Connect Math. So they have the Show Me, also the instructional tools. And then you have the suggested YouTube videos, which we've always used in the past, but now we have this new feature of Zoom. It just takes time for your instructor to, record those separately. And once they get processed, I post them in the COREC course. Okay. So in our workbooks, if we go to that section it's called linear inequalities, and it's noted as 9.7. Um, so I'm thinking there aren't any page numbers, and I apologize for that in the COREC book, but since it says example 9.7, then that might, if you reference that from your textbook, that might come from chapter 9, section 7. Let me just check that out right now and see. I have my book here because it says example 9.7. Then I do see at the bottom it says McGraw-Hill. So it's coming from a McGraw-Hill product. Just don't know if it's from your stats book or from another, algebra textbook. I'm not sure. Let me just see what 9.7 is in our book. Where are they getting these examples from? Yeah, because in our book, chapter 9, you can see that's testing the difference between two means, two proportions, and two variances. So we're not going to see a 9.7 related to linear inequalities there. And if I go to the beginning of the book, it starts with chapter 1, which was our quiz 1 material. If I go to the back of the book, well, I do see here in the back of the book, it says additional topics online. So www period MH for McGraw-Hill education. So MHHE period com slash backslash, and that's our textbook Blumen. But it does have a little bit of an algebra review there. So I'm not sure, but no matter, this is the curriculum that was assigned to us for the COREC when they was set up. All right, so let's see what we have here. Just move this to the side so I can see. All right. So here it says that we're graphing linear inequalities. It says the solution to the inequality x is greater than or equal to 2 is all real numbers 2 or greater. So we have x is greater than or equal to 2. And I don't know if you can tell there, but they've highlighted on the endpoint 2. Notice how on the endpoint 2, it's it has a bracket as opposed to a set of parentheses. Notice how it's shaped. It's shaped to the right. Notice how it's shaped in the direction that the inequality is being shaded. So that's important also. And then the arrow tips also are shaded. Okay. And so this underscore, I call this an underscore. See that little line there? Greater than or equal to? That's an underscore. And what that tells us is that tells us to include the endpoint. Which in this problem, the endpoint is a 2. Okay. And again, this is red. X is greater than or equal to 2. So this is red. X is greater than or equal to 2. Let's emphasize that. So it does say the square bracket symbol is used on the graph instead of the parentheses to indicate that the point x equal 2 is included in the solution. By convention, square brackets, and they have them here shaped, are used to include a point on a number line. Parentheses, and they have examples here, are used to exclude a point on the number line. Yeah, so if you have parentheses, the graph will approach to very close to that endpoint, but it won't actually include it, won't actually touch that. So it approaches it. Okay. Okay, let me put at the top here the title. So this is correct number 8, and we are reading and graphing linear inequalities. Okay. Okay. Now, in this exercise, they're talking about writing set notations. That's going to come up on one of our pages. So I'm going to actually go ahead and also do something extra. I'm going to go ahead and write the set notation for this. Okay, so this would be the set notation for that. I would have open set of braces. I would introduce the variable we're talking about, which C is X. And in math, we use this symbol. This symbol means such that if you were a professional secretary, you use shorthand. So we borrow some information from that, means such that. So the set X such that, and then you write your solution. This is our solution. X is greater than or equal to 2. And then we close those curly braces. Okay. So when you're asked to write a set notation, the first thing, the steps in your steps, the first thing we say is that all set notations begin and end with curly braces. So set notations, they begin and they end with those curly braces. They're a little hard to draw. Just don't make them look like a bracket and don't make them look like a parenthesis or the other one in between. And they are on your computer keyboard by the P and on the where the bracket is at, there's the curly braces. So you can see that on your computer keyboard to get a good look at what it looks like. Okay, so you can see here how I begin it and I end it with the curly braces. And then you introduce the variable. So you introduce the variable. Introduce the variable. So in this case, we're talking about X. Sometimes you talk about different letters, W's, Y's, M's. So whatever variable you're using, you introduce that, introduce the variable, which is X. And then we use the such that symbol, which is this. Okay, so that's this right here. And then you write the solution. So the solution was X is greater than or equal to 2. See? So you see the solution set. So you write that. And then you close the curly brace. Okay? And that's how you write a set notation for a graph. So it's just another way to express a solution, and it's just more formal in an algebra course. Okay, but since they do talk about that, there's a page coming up and they do talk about that. That's why I'm going ahead and writing that down. And on the bottom, at the bottom, we have here this X is greater than 2. So the solution set of the inequality, and this is red, X is greater than 2. So notice it doesn't say X is greater than or equal to 2. Notice how it doesn't have the underscore. Okay, this includes the real numbers greater than 2, but not including 2. So I'm going to underline that or highlight that, not including 2. Therefore, a parenthesis symbol is used on the graph to indicate that is equal, that X equals 2 is not actually included in your graph. And so if I highlight this, because you can barely see it in my copy, but on the 2, there is a parenthesis right there, and it is curved in the direction that you're shading. So this is where all your unknowns. This is reflective. You want to shade. You want to shade to the right of 2. Okay, shade to the right of 2. And that's because this is reflective of all your unknowns being greater than 2, greater than 2. And again, you use parentheses. I'm going to put an I here. I think they do parentheses, right? Parentheses. They use an E here because they have plural, right? 2 of them. Here we have 1, so I'm going to use an I. So parentheses, I have 1 of them here. So we use parentheses to not include the 2. And remember, they use the word exclude. They excluded, remember? So 2 is not included. Yeah, so you exclude. Over here, they talked about excluding the point. Okay. So to graph inequality means that we graph its solution set. That is, we graph all the values on the number line that make the inequality true. And it's also important that you're in it. This is your in it. These are inequalities. It's also important that they always insist that the variable go first. You have the variable, then the inequality, and then the constant. So you do have a format, an inequality, an inequalities format. An inequalities format is you have the variable, and then you have the inequality, and then you have the constant. So the variable, the inequality, and then the constant, they do insist on that format. Okay. So later on, there's going to be a problem where it's like out of order because they don't have the variable first. So then we'll switch it up, we'll rearrange it so that the variable is first. Okay. And then if I also write the set notation, I ask you to write the set notation for this. Remember, all sets begin and end with curly braces. You would introduce the variable, which you see happens to be x, and then you use this little bar, this little stick here. This bar means such that, and then you write your actual solution. X is greater than 2. That's like our solution. And then you close the curly braces. Okay. So remember, this bar means such that. Okay. All right. Okay. So now let's look at the next page. Let's see. So they want us to graph the solutions. We're going to graph them. We're also going to write the interval notation. And we're also going to write the set notation. Okay, so for the first one, for this A, we have x is greater than -1. Okay, so we write a graph for that. Notice how the order is good. The variable is first. Here the order is good. Variable is first. This is not good. We're going to have to fix this one. This one, we're going to have to put the variable on this side and the constant on the other, and we'll have to swap that. So this one we'll have to fix. Okay. Um, so let me do that right now. So this is good. Order variables first, variable first. Here, the variable's not first. So technically the y goes here. The 3 goes over here. And of course, this is going to have to change. So this is still pointing to the y. Okay, so you can, this one requires, this requires a rewrite. Okay, but now that's good. All right. Okay, so now we'll be able to graph these. Okay, so we'll start with this one first. So the graph, I'll draw a generic number line, and I'll just plot 0 just to give me a rotation, and then -1 is right here. And this is saying that all our unknowns are greater than -1. Okay, and don't include -1. Okay, so I'm going to shape it in the direction that I'm shading. Okay, so I'm shading to the right of -1, and I'm using parentheses. Okay. So also the reason why you want the variable on this correct side is see how this is pointing, just point. See the sharp edge point to the right? That means you're going to shade to the right. Okay. If it has this format. Okay. And then the interval notation. Okay. Well, the interval notation, it mimics the graph. It mimics the graph. It's a snapshot of the graph. And we study and record the, the like the highlighted parts of the graph, the highlighted shaded parts of the graph from left to right. So when we study this graph from left to right, the first thing you see is this -1 that's highlighted in parentheses, comma, and then you see shading, 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 and then look at this. Look, this, it's shaded forever. This is negative infinity somewhere on this side, positive infinity somewhere on this side. So you're not interested in the negative infinity because there's nothing shaded over here, but you are interested in this positive infinity because see, it's shaded forever in this direction. And that's how you're going to record this as a positive infinity. And then this is by definition. By definition, all infinities, whether they're a negative infinity or whether you're using a positive infinity, by definition, all infinities are associated with parentheses. And one of the reasons why, like the mathematician who did the work for that, I'll put that in. That's because of L'Hopital's work. So it's L and then like a comma H. I think OP Hopital, I believe. So Hopital's work. Yeah. So like in pre-cal and calculus, he did work with limits. And so because of his work, that's kind of the reason why, by definition, all infinities are associated with parentheses. Yeah, so you wouldn't, a bracket wouldn't be best. A bracket wouldn't be appropriate because a bracket means you actually include that endpoint. And the thing is with the parentheses, someone can always take it out farther out. So if someone says, I want to take it out to 100, someone else can come around and take it past 100 to like 105, and someone else can come back and take it out farther out to 200. So there's no limit. It just goes on forever. That's why a bracket wouldn't be appropriate. Parentheses is better. to show that because it doesn't actually include an endpoint. Someone can always take it out further out. Okay. Okay, so that's your interval notation. So we had our graph, we had our interval notation, and now we're going to have the set notation. So in our set notation, remember we have open braces. We introduce the letter we're talking about, which is x, such that x is greater than -1, and then we close it. Okay. Okay. So now for this next one, c is less than or equal to, and that's 7/3. Okay, so I'm going to do long division because I'm not sure like where is 7/3 at, right? So I'm going to do numerator divided by denominator. 3 goes into 7 twice, 1 left over, and I'm going to record it clockwise. So this looks like we have c is less than or equal to, and that looks like it's 2 1/3. Also, if I want to do just to give me an idea of the decimal, 7 divided by 3 is repeating 2.3. So C is less than or equal to 2.3 with the bar over it. Okay, so that's also helpful. It doesn't hurt to do that. Usually usually the rule of thumb is they don't want decimals included in answers unless the problem starts off with decimals, and it doesn't. So, but it doesn't hurt to still give you an idea of where the 1/3 sits. So it's at 0.3 approximately. And so our graph for that, I have 0 just to give me orientation, and then a tick mark. And now I know that gives me an idea. So if I do 1, 2, that gives me an idea here that this is just a little bit past 2 right here. And that would represent the 7/3. So it represents the 2 1/3, the 2.3 repeating. Okay, so but we were introduced to it as 7/3. Okay, so then this is saying that all your C's, all your unknowns are less than or equal to. So all our unknowns are less than or equal to 7/3. So I'm going to shade to the left of that, and I am going to use a bracket here. See that bracket? And then shade all that. So you want to shade to the left of 7/3, and you want to use a bracket. And you're using a bracket to include the endpoint, 7/3. Okay. And then your interval notation is, remember, a snapshot of your graph. And remember, we read graphs from left to right, left to right. So, and you focus on what's highlighted and what's shaded. So first you see the negative infinity. See, this is action on negative infinity. So you have parentheses, negative infinity. Remember we said by definition, all infinities are included by definition with the parentheses. And then we follow it from left to right, stops right here at the 7/3, and it's a bracket. Okay, and then we have the set notation. So we have braces, and this time we're talking about C such that, and then C is less than or equal to 7/3. Okay, next, this one we already rewrote this one. See, it just says 3 is greater than y. So you've got to rewrite this one. You have to follow the order: variable, inequality, constant. So we have y is less than 3. So in our graph, here's 0, here's 3. Y is less than 3. So we're shading to the left. And then we're using parentheses. Okay. So all are unknowns. Are less than 3. So you shade to the left of 3 and you don't include the endpoint. So that's why we use a parenthesis. And so the interval notation, it's a snapshot of your graph and you read it from left to right. So again, you see on the far left, that's reflective of negative infinity. So you have parenthesis, negative infinity. By definition, all infinities, whether they're positive or negative, those are always associated with parentheses. They don't actually include any endpoints. So negative infinity, and then you read it from left to right, and then it terminates here at 3, and then it's got parentheses on that. And then the set notation is curly braces, y here, such that y is less than 3. Yeah, so you put your solution and you put this rewritten part solution. Okay. Okay, so now the next page, this is what I've already gone over. So it just reinforces the set builder notation. This says the set of all x, and then this little bar I told you means such that x is greater than or equal to 2. And then the interval notation, it just says the interval notation to say this: x is greater than or equal to 2. So you can barely see that, but you can see that they've have a bracket here at 2, and then this is all highlighted. So they're saying that this is, they read it from left to right. Here's your bracket, and then this is the infinity, right? So we have negative infinity to infinity. So they're emphasizing the infinity. Okay, so we're reading them from left to right. And then at the bottom, they have some detail about the interval notation, that the endpoints used in interval notation are always written from left to right. That is, the smaller number is written first, followed by a comma, followed by the larger number. So we talked about that left to right. Parenthesis indicates that an endpoint is excluded from the set, whereas a square bracket indicates that an endpoint is included in the set. parentheses are always used with negative infinity and with positive infinity respectively. Okay, so that's exactly what I was saying. And then here, this is in black and white. My copy is a lot nicer. See how mine's in color there? So let me see if I can highlight this. So here, this is, you can barely see this graph, but this is parentheses, and this is shaded in this direction. Here, this graph, this is parentheses and shaded in this direction. Here you have both parentheses, and this is sandwich, compound inequality. Here you have parentheses and then a bracket, sandwich in between. Over here you have a bracket, parentheses. Yeah, this is infinity, so this is shaded forever in this direction, infinity. And this one also had infinity. This one had negative infinity in here. These are trapped in between. These are compound in between. This is a bracket. This is negative infinity. These are trapped in between, and these are brackets here. Here, this is a bracket, and then parentheses. It's a little hard to see that, but there you're getting that from here. Okay, just kind of hard to see that. Okay, then down here on the graph, let's see. This is a parenthesis, negative infinity. Here, this is a bracket. Infinity. This is compound, so it's a, looks like it's a, you see, put my glasses on, that's so small. What is that? Bracket on the -2. And it looks like parentheses on the 4, no underscore, no underscore. So bracket on the -2 and parentheses on the 4, no underscore, and then that's shaded. Yeah, so it was not a very good copy of, that's not a very good black and white copy of that. Maybe yours copy came out better, but that was to go over that on mine. So there's just, those are samples, right? They're samples of generic examples. Okay, so let's see. So here's an example of compound inequalities. These are compound inequalities. So these are like sandwiched inequalities. So that's like these when your numbers are trapped. See, they're trapped. See, they're trapped in between. So no infinities. Compound inequalities, there's no infinities, no negative infinities, no positive infinities, are trapped in between. So let's say they ask you to graph the solution set of the inequalities. Okay, so let's say we had this M let me make this plural, inequalities. Okay, so let's say we have this -8 is less than or equal, but let me read it like this. M is trapped. M is trapped between -8 inclusive and M is trapped between -8 inclusive and 5.5 exclusive. So you see how this has the underscore? This has the underscore where this one doesn't. Okay, so when I make my graph and I have 0 just to give me orientation, and I have -8, and I have 5.5. So then on the -8, because there's an underscore, I have the bracket. And on 5.5, there's no underscore, so I have parentheses. And then I shade everything in between. So all our unknowns are trapped. All our unknowns are trapped between -8 and 5.5. Okay, so our unknowns they're basically trapped right in between, right? But they include the -8, but they don't include the 5.5. They just approach 5.5. They don't actually include that. Okay. And then that's the graph. Okay, then we're going to do the interval. We read it from left to right. So we have the bracket, -8, and then the 5.5 parentheses. And then the set notation, curly braces, M, such that, and then you write this entire solution. Okay, then we have another one using T. T is trapped. T is trapped between -4 and -4 exclusive, and T is trapped between 9 inclusive. You see the underscore? Okay, so you have -4 and then 9. So on the -4, you have parentheses, but on the 9, you have bracket, and shade all that in between. And then your interval read from left to right, left to right. So you have parentheses, -4, comma, and you have 9 bracket. Okay, it's a snapshot, mini snapshot of the graph from left to right of what's highlighted. And then your set, curly braces, T, such that, and then you write all the solution down. Okay, so let me see these. That's the general idea of the lesson. I think I just had a few extra examples here that I'm looking at that I showed in the past. Let's see. So let's say that this is given. Let's say they give you that, okay, which is an interval, right? That's a given interval. And then let's say they ask you to write a graph and a set builder. Okay, so the graph for this would be you'd have to plot 0, -4, -7. Okay, and then you want brackets on those endpoints and then shading in between that. Okay, so that would be your graph. And then set notation be curly braces. Now here, they don't tell us what the variable is. So on a set builder notation, we're going to use variable x because we don't see it otherwise. So we'll just use x such that, and then this would say that these are trapped between -7 and -4. Okay, see the little underscores? So they're trapped, okay? Okay, let's say that this was given. -4 to infinity. So then they want you to write the graph for that. And also set notation, set builder notation. So here's 0, here's 4. Oh, it's -4. So -4 is over here. So you have -4 all the way to infinity. So then this would be bracket on -4, and then you're shading all the way to infinity. That's your graph for that. And then the set builder notation would be the set x. We're going to use x again, such that, and this is saying that all your unknowns are greater than -4. So all your unknowns are greater than or equal to, because of this bracket, -4. Okay, so we're using the x variable right here. Okay. Okay, given interval, parenthesis, -infinity to 3. We're going to write a graph and a set builder. And we're going to use variable x. I have 0, 3. Okay, I'm going to use parentheses on the 3, and I'm going to curve it in the direction I'm shading. I'm shading to the left. That's reflective of negative infinity. So there's my graph. And then my set builder is I'm going to use x again, such that, and this is saying that all my unknowns are less than -3. Less than 3. Okay, and then last one. Okay, so here we're given the set builder notation. So let's see, these are the set builders. Remember, set builders. So here we're given the set builder notation. The set y such that y is greater than or equal to -5. Oops. Okay, so your graph. So here's 0, here's -5. So I have a bracket on -5. And y is greater than, so we're shading this direction. All your unknowns are bigger than that, equal to. And then your interval is bracket -5 all the way to, this is, see, positive infinity, parenthesis. Okay. All right. Okay. So that should help you with your homework set then. Okay. For your correct, this is for your correct on, what number was this? Number 8, right? Yeah, correct number 8. Okay. So good luck with that then. Okay. Finish your homework.